It's Thursday, the 28th of June, 1990. Here, in the north of Scotland, British Telecom is about to pass another milestone.
Hello, Supervisor. This is the engineer's calling from Thurso. We're just about to commence a transfer. Could you confirm for me, please, that there's no 999 calls up at the present moment? Fine. Thank you very much. If you just stand by, we'll come back to you. Okay, Ernie. Commence a transfer.
Hello, Gordon. Data in at Inverness, please.
Thurso is not a place normally associated with such achievements. Today, though, at precisely 1 p.m., the last analogue switching unit in the United Kingdom long-distance telephone network will be taken out of service.
Okay. Right. Cut out the old exchange, please.
This was the last act in a giant undertaking that has given the United Kingdom the most advanced major long-distance network in the world.
Morning all. Good morning. Good morning, Colin. Good morning, Kate.
Early in the 1980s, the decision was taken to provide the United Kingdom with an entirely digital long-distance trunk network.
Have you all got a copy of this?
The multi-million-pound investment programme was planned. The ultimate objective was to set up a completely digital telecommunications network throughout the country. Ambitious? Certainly. But there would be enormous benefits for everyone. But why change? What are the advantages of digital communications? Our speech is made up of a range of different frequencies. The telephone converts this signal into an analogous electrical waveform. This is switched and transmitted to its destination by the network. During transmission, this analog signal can pick up noise. When it's amplified, as it needs to be several times, the noise is also amplified. The noise level builds up, degrading the sound.
This is a bad line. I'll call you back.
Converting the speech to a digital signal, which is just a series of on or off pulses, makes it very resistant to noise. This is because if any part is degraded, it is still easily recognized as either an on or off pulse and can be regenerated. There is therefore very little noise, giving a digital network much better quality of transmission. There are other benefits. Digital equipment is much more resistant to failure than analog. The exchanges in the network can switch the call more rapidly and effectively. The digital signal can also carry information about the call itself, such as its full destination. This also allows the network to be managed in a more efficient way. In the old analog system, individual telephone lines were connected to one of the 6,000 or so local exchanges. These were in turn connected to one of the 424 long-distance exchanges, or the switching units. A further network of over 30 switching centres was connected to these exchanges for very long-distance calls. The system worked well, but could be sensitive to mechanical breakdown or sudden large traffic loads, because there was only one route for a given call. In the totally digital network, the local exchanges are connected to a minimum of 2 of the 50 or so fully interconnected digital main switching units. This makes the network more flexible and gives it much greater resilience to failure. On the rare occasions when there is a problem, there are always alternative routes which can be used. The Wild West, Jesse James, Wyatt Earp and all that, may appear totally unconnected with communications, except for the fact that this man, Ormond D. Strowger, was losing business. He was an undertaker, no doubt a growth industry in his backyard, but he thought that telephone operators were being bribed to divert calls to his competitors. So he came up with the idea of an automatic system. By the 1930s, improvements to Strowger's ideas were taking place. The crossbar system was introduced and proved more reliable. By the time BT began modernization of the long-distance network in 1985, the switches at the exchanges were Strowger and Crossbar. The Kansas City undertaker had earned a place in history, and now his invention was being laid to rest. Imagine updating a transport system based on horse-drawn travel to one based on the petrol engine and a network of motorways. That was the extent of the challenge facing the BT project team. There were no doubts that the totally digital network was the best and most cost-effective option for British Telecom customers. The next step was to build it. Several key objectives were part of the overall strategy. It was decided to carry as much traffic as possible, as soon as possible, on the growing digital network. This would bring quality of service benefits to the customer right from the start. But for the engineers, it presented a real challenge.
Okay, start.
To achieve this required temporary interworking routes between the old and the new networks. The closure program of the old long-distance units was determined by what would be most economical while providing the best possible service. Some were taken out of service right away. Others remained in operation until the end. In this way, British Telecom were able to make significant savings while giving its customers the advantages of digital technology as early as possible.
Hello, good morning. This is British Telecom. We're just ringing up to tell you that we've changed the exchange to digital this morning, and I want to check that your PBX is working correctly.
Implementing the plan proved to be a game of many variables. Essential strategy changes within the local network and alterations in how local exchanges were connected to the long-distance network affected the project. Equipment delivery dates and manpower availability were two more crucial factors. All the time, the modernization program of local exchanges was proceeding rapidly. It needed to be coordinated with the evolution of the long-distance network. At the outset, call growth had been predicted to be 30% over the period of the project. In fact, there was an unprecedented explosion in the use of telecommunications, including telephone, facsimile, and data transmission, giving an increase of nearly 70%. All this meant problems were inevitable. It says much for the teamwork and commitment of the staff involved that the project was completed on time. Furthermore, all the initial objectives were achieved. Perhaps most important of all, the changeover was accomplished without breaks in customer service. The benefits extend to the full length and breadth of the British Telecom network, bringing the same quality of service to everyone, regardless of where they live or work.
Good afternoon, English Country Cottages. Can I help you? Would you like to go to Somerset on the 22nd of September for 1 week?
Digital operation also makes possible an enormous range of new services, such as the Integrated Services Digital Network, encompassing speech and data, as well as high-speed fax and slow-scan TV. To give one example, time of day routing. This enables a customer to change from many centres answering calls during the day to 1 or 2 at night. No calls are missed, and large savings are made during periods when calls are few. Digital equipment is robust, and failures are very rare. The need for on-site maintenance is small. Furthermore, the transmission and switching equipment is subjected to computerized monitoring techniques at specialized operation centers. This means that the few faults that occur are identified very rapidly. Then, action can be taken to rectify the problem.
Hello, Staley Bridge. This is the NOU in Manchester. We've had a trunking junction failure on one of your circuits. It's failing excessive backward loss. Can you possibly try changing the channel card for me? I'll try it again. Thanks very much.
The result is that breakdowns are repaired quickly, giving a more consistent and reliable service. This is borne out in the statistical results of the network. In early 1987, when only about 25% of long-distance calls were being carried on the fledgling digital network, 5% of calls were lost. In 1990, when all calls were digital, less than 1% of calls were lost. In addition, the digital switches or processors produce information which enables the network to be managed in real time. That is, the traffic can be controlled to improve the service by rerouting calls to avoid temporary problems. In this way, telecommunications traffic can be likened to road traffic. If a route becomes overloaded, the flow can be maintained by rerouting some of the traffic on side roads. If it's a major problem, the telecom traffic manager has a significant advantage. Traffic can be sent on very wide detours, and there's no delay. It takes less than 1/10 of a second to go around the world. The rerouting is originated and controlled by the Network Management Center. Any problem is brought to the attention of the managers on their screens. The United Kingdom has the most advanced major long-distance network in the world. This is an essential part of the larger task that British Telecom has set itself: to provide a totally digital telecommunications network throughout the land, with connections across the globe. A full range of quality services second to none will be available to all parts of the country. There will be new business opportunities, a wealth of potential to outlying areas and inner cities alike, bringing to all British Telecom customers the ultimate benefits of telecommunications.